Can we change the laws of physics in our surrounding world or not? For many years, scientists believed that the universe follows fixed and deterministic laws. However, with the emergence of quantum physics theories, we have come to the conclusion that our world is made up of probabilities that even we can influence. In the second chapter of The Great Adventure, we will enter the mysterious realm of quantum, and with the help of science and incredible wonders of the quantum world, we will examine whether we have the ability to control the laws of physics or not. Quantum is a Latin word meaning how much or a specific amount. In simple terms, quantum physics examines the smallest building blocks of this universe. For example, photons are quantum particles that constitute light, and quarks are quantum particles that make up protons and neutrons. Quantum particles have very specific properties and behaviors and do not follow any definite laws. The behavior of particles at the normal level and quantum level cannot be compared at all, and there are significant fundamental differences between them. In other words, quantum particles exist in a countless set of probabilities, and in the quantum realm, nothing is impossible and anything can happen. Feeling confused? Don't worry. Even the greatest scientists struggle to fully understand quantum concepts and get puzzled. The good news is that today we are not going to delve into details of quantum physics. We are just going to briefly explore some of its concepts. Einstein believed that light is the fastest thing that exists, and nothing can exceed the speed of light. However, at quantum level, the laws are completely different. One of the discoveries of quantum physics is a concept called entanglement, which is considered one of the biggest differences between classical and modern physics. In simple terms, when two quantum particles become entangled for a specific reason, a change in one of these particles immediately causes a change in the other particle. The interesting point is that even if these two entangled particles are separated by thousands of light years, creating a change in one of them still immediately affects the other particle. Einstein called this strange phenomenon spooky action at a distance, because there was no real description for it. However, quantum physics has made remarkable advancements today and has been able to prove these strange concepts. Currently, we know that quantum entanglement is completely real, and this concept will reveal many mysteries. Now, if the Big Bang was the starting point of this universe and everything was created from a tiny particle, it is possible that all the quantum particles that make up the universe are entangled. This means that if you can control and change a particular particle, you may have put all the particles of the universe in a state of change and transformation. Remember the concept of entanglement up to this particular point, and please try to think about it as much as you can. But we have a lot more to explore with this concept, and this is just the beginning. Now, let me ask you a few questions. Please pause the recording after each question and think about it. The first question is, why are the universe and everything in it the way they are now? Could they have been different? Please pause the recording for a few seconds and contemplate this question. The second question is, why are the laws of physics in our world the way they are now? Could these laws have been different? Please pause the recording again and think about it. We all have different answers to these questions, and there is no right or wrong. But do you think it is possible for all these different forms, states, and laws to coexist simultaneously? I know it can be confusing, But please rewind the recording for a few seconds and think about these three questions that were raised. If you haven't thought about the questions, I'll be upset with you. But if you have, I'm going to tell you a very strange and interesting concept. Of course, I'm still upset with those who didn't think about it. In quantum physics, there is an interesting concept called the wave function. The wave function, in simple terms, represents the probability distribution of quantum particle. It describes that a quantum particle does not necessarily exist in a specific state, but can exist in multiple states simultaneously. In other words, at the quantum level, you are not necessarily a specific person in a particular location. Instead, you can exist simultaneously in multiple places and, for example, be both alive and dead. In summary, a quantum particle can be in any state and anywhere and does not adhere to any specific law. However, the interesting point is that when we observe that particle, out of all the different possible states, it selects only one state and its wave function collapses. We can say that a quantum particle knows it is being observed and takes on a specific property and state based on the observer's perspective. I suggest that you pause the file right now and watch a video of the famous double-slit experiment. By watching this experiment, the concepts I have mentioned will become clear to you. In short, the double-slit experiment shows that quantum particles in their fundamental state possess wave-like properties. However, when someone observes these particles, they no longer exhibit wave-like properties and manifest themselves as particles. As I mentioned earlier, quantum particles become aware that we are observing them and take on a specific state based on our observation. At first glance, you might think this is impossible, but later you will realize that this is entirely true and has been proven through various scientific experiments. The concept of the wave function and its collapse upon observation is another important scientific concept that we will work with extensively in the future. But the point here is that you have found the answers to those three main questions. Please go back and answer those three questions once again. I hope you have understood the content of this chapter, and if you still feel confused, it is completely normal. So don't worry. By reviewing these materials, the concepts mentioned will become clear to you. In the second chapter of our grand journey, we examine some of the basic concepts of quantum physics. Concepts such as entanglement and wave function are important for understanding the topics in the following chapters and will greatly assist us. In addition to these concepts, we also discussed a very important and fundamental concept in the first chapter of this journey. If you don't remember that concept or haven't seen the first chapter yet, please immediately go to the first chapter after this one. If you want to uncover the strangest secrets of the universe and achieve wealth and success in the grand journey, you need to start from the first chapter and not proceed to the next chapter until you have fully understand the contents of a chapter. Once you have a complete understanding of the first and second chapters, we will see each other in the third chapter of this journey. I promise you that the third chapter of this grand journey will astonish you.